Good morning, Year 12. In today's lesson, we're going to look once again at compound interest, and this time how we can find the future and present value of an investment or a loan. So in the box here, we're asked to remember the compound interest formula that we revised earlier this week. So A equals P outside of 1 plus I to the power of N. We know A is the future value, P is the principal or the present value, I is our interest rate as a decimal per compounding period, and N is the number of compounding periods. Our first example is $3,200 is invested for 4 years at 7% per annum compounding 6 monthly, and we're asked to calculate the future value of that investment. So we're starting with our compound interest formula here. Over to the side, I'm going to work out my I and N values. So I know that this is compounding 6 monthly. My yearly interest rate was 7%. As a decimal, that becomes 0.07. And because it's compounding 6 monthly, I'm going to divide it by 2 to work out the interest rate per 6 months. N is the number of compounding periods. We know that this investment is happening for 4 years and it will compound twice every year. So that gives us a total of 8 compounding periods over the term of the investment. When I put all of those values into my formula, I'm getting an answer of $4,213.79. You'll see here underneath that I've written, is this reasonable ? We know that evaluating the reasonableness of our solutions is one of our 6 syllabus objectives, and therefore it will be something that will be assessed in your external exam. So in a question like this, how could we evaluate whether our answer here is reasonable or not? An easy way to do that would be just using common sense. We know that we've started with $3,200, and if we're asked to calculate the future value of our investment, then we'd expect that our investment had grown over 4 years. And the fact that our answer here is higher than the $3,200 we started with would be one way that we could justify that our answer is reasonable. Our second example, Tina borrows $40,000 at 4% per annum compounding daily. Calculate the amount of interest this loan will accrue over the 7 years. Once again, it's a compound interest situation, so we've got our compound interest formula. Compounding daily, so when we work out our I value, 0.04, which is the 4% as a decimal, divided by 365 days in a year. When we work out that value on our calculator, once again, it's a really long decimal that I don't want to have to write down all the decimal places for. And you'll notice I've written here to the side that your textbook rounds that value to 4 or 5 decimal places. We shouldn't be rounding these values and then carrying them into another formula, because that's not going to give us an accurate result. So as we've seen in previous lessons, I've taken this fraction over into my compound interest rule so that I can retain its exact value. For N, this loan is for 7 years, and because it's compounding daily, it's going to happen 365 times in every year. So that means that in total, this loan is compounding 2,555 times. When we put all of those values in, we get $52,924.38. It's important that we always go back and read what the question is asking us to find. So in this case, the question wants us to find the amount of interest the loan is going to accrue. So far, all we've found is the future value of the loan. This is the balance of the loan after the 7 years. So to find the amount of interest that we will be paying on this loan, I'm going to take that final amount and subtract the principal, which is what I've borrowed. The rest of this final amount must be the interest. So the loan has grown to $52,924.38. Subtract the $40,000 that Tina borrowed at the beginning of the loan, leaves $12,924.38, which is the interest component of what she's going to have to pay back. Our last worked example, Tamara would like to have $20,000 in her account in 5 years. If the interest is 3.8% per annum compounding quarterly, how much does she need to invest now? In a question like this, they're actually asking us to find the principal or the present value. So we've still started with our compound interest formula, and this one is compounding quarterly, so our I value becomes 0.038 divided by 4, and our N is 5 years times 4 times per year, gives us that it is going to compound 20 times. The I and the N value go in here, and this time the $20,000 is what she wants to have in the future. So that's the total amount or the final amount that she wants to have. In order to find out what the principal is, or the initial value, then we are going to have to use some basic algebra here. We know that the principal is being multiplied by 1.0095 to the power of 20. So if I move that to the other side and do my opposite operation, it will be 20,000 divided by 1.0095 to the power of 20. Once again, you'll notice here that I have not worked out the value of this first. The reason for that is it's going to once again be a long decimal that I don't want to have to write out all the decimal places for. So I've simply taken it to the other side first and then put it all into my calculator in one step. Gives me a principal of $16,554.02. If we needed to evaluate the reasonableness of that solution, this time because we were trying to find the initial value, we would expect that the initial value would be less than the final value of 20,000. And that would be, we could explain that, and that would be enough for our justification of the reasonableness of our result. That's the end of the work for today. On OneNote you'll find some textbook exercises, and you'll also find a short 4-question worksheet to complete today.